Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
For today's lesson, I'm going to focus on the conjugate pair theorem in the complex number chapter. So what is conjugate pair theorem? So the definition is over here. If px is a polynomial of real coefficients and a plus bi is a root of the polynomial, then a minus bi is also a root of the polynomial, which means the complex root comes in conjugate pair. So if a root is a plus bi, then the other root will be a minus bi. So have a look at the question here. Show that negative 2 plus 3i is a root of this equation. So how to show that negative 2 plus 3i is a root of the equation? It's the same as the normal question. How to show that x equals to 2 is a root of the equation? We just need to sub in x equals to 2. So the same thing here. We need to substitute this one into the x here and show that it's equal to 0. So if it's equal to 0, that means negative 2 plus 3i is a root of the equation. So what we need to do now is just substitute negative 2 plus 3i into the x. Negative 2 plus 3i plus 13 and show that it's equal to 0. So what to do is you have to open up the square. So negative 2 plus 3i, when you square it, you get 4 minus 12i plus 9i squared minus 8 plus 12i plus 13. Alright, so the negative 12i and positive i can cancel off, and you'll be left with 4. I squared over here is a negative 1 times 29, you get negative 9 minus 8 plus 13. So eventually you will get a 0 here. This is how we show that negative 2 plus 3i is a root of the equation. So second part here, to deduce the second root of the equation, since we know that the first root is a complex root, then automatically the second root will be the conjugate root. So the second root here, you can straight away write negative 2 minus 3i. This will be the second root, which is the conjugate of this. What if you are not given the root of the equation, but they change the question in this way? You are asked to solve this equation, x squared plus 4x plus 13 equals to 0. Usually what you do, you just take out the calculator and just get the answer through the calculator, isn't it? So for this equation, if you try to check by using your calculator, the calculator will show you that the answer is actually in complex number. The calculator will show you these two roots, negative 2 plus 3i and negative 2 minus 3i. But during the exam, of course, you can't get the answer straight away through the calculator, because this type of question will actually give you about 3 marks. Therefore, to solve this equation is actually a quadratic equation. If the answer that you get from the calculator is a complex number, is a complex root, then the proper step to get the answer for this equation is by using the quadratic equation, which is negative b plus minus square root of b squared minus 4ac over 2a. So this formula is actually provided in the formula sheet in case if you forgot about this formula. So now let's apply the ABC into this formula, which is negative 4 plus minus square root of 4 squared minus 4 times 1 times 13 over 2 times a. So the a is a 1 here. Right, so we will have 4 squared, which is 16, minus 4 times 13, we will have square root negative 36 over 2. Okay, take note here. What is square root negative 36? In P1, you say that we cannot square root a negative value, but in complex number, we can square root a negative value because we can actually let the answer in the form of I. So what is square root negative 36? You can highlight it here. Square root negative 36 is actually square root 36 times square root negative 1, which is equals to 6i. So now we can proceed with the solution. Becomes negative 4 plus minus 6i over 2, and hence the answer will be negative 2 plus minus 3i. So you notice that this answer is in conjugate pair, plus minus here, and that's why there's something called conjugate pair theorem. Let me show you some sample passage question on how to apply the conjugate pair theorem. Have a look at this year, May-June 2019, variance 32. So throughout this question, the use of the calculator is not permitted. It's given that negative 1 plus square root 3i is the root of the equation. So in part 1, you are asked to write down another root of the equation. So since you know that one of the root is a complex number, according to the conjugate pair theorem, another root will be the conjugate of this complex number, which is negative 1 minus square root 3i. Then you can get the 1 mark easily. That's how we answer the part 1 according to the conjugate pair theorem. As for the part 2, find the value of k and the third root of the equation. So to find the value of the k here is very simple, because given that this is the root of the equation, you can just substitute this root into the x here, and it will be equal to 0 because it's a root of the equation. Let's try it now. So substitute negative 1 plus square root 3i into the x cubed with a k in front of it, plus 5 times negative 1 plus square root 3i to the power of 2, plus 10 times negative 1 plus square root 3i, and plus a 4. Alright, for now, we have to expand for this power 3 and the power 2. So usually what I'll do is I will expand for the power 2 first. So now we have negative 1 plus square root 3i power 2. It will be equals to 1 minus 2 root 3i plus 3i square. So I square here, change it into negative 1, which means this value becomes minus 3. So you combine it with the real part, 1 minus 3, you get negative 2 minus 2 square root 3i. Then you can substitute it into this part later for the square. As for the power 3, negative 1 plus square root 3i power 3 is just by using this value, negative 2 minus 2 root 3i, times with negative 1 plus square root 3i again. So from here, you can open up 1 by 1. Negative 2 times negative 1, you get a 2. Then negative 2 square root 3i plus 2 square root 3i and minus 6i squared. Then we will have an 8. Alright, so this one you can substitute into here. And hence, we will have 8k plus 5 times negative 2 minus 2 square root 3i, and open up the bracket over here, you will have minus 10 plus 10 square root 3i plus a 4 and equals to 0. And hence, open up the bracket again, you will have 8k minus 10 square root 3i minus 10 again plus 10 square root 3i plus 4 and equals to 0. So you notice that these two cancel off, and hence the 8k should be equals to 16, and therefore the k's answer is equals to a 2. That's how we solve for the second part. And don't forget, there's another part in the part 2. Find out the third root of the equation. So we know that the first root is over here, -1 minus square root 3i. Second root is over here, -1 plus square root 3i. So since the equation is x power 3, have a look here, x power 3. That means there should be 3 roots. So how to find out the third root? To find out the third root for the part 3, of course you can check by using calculator, but the steps to show the third root of the equation is actually to factorize it. So I have substituted the k into the equation here, and this is the equation. So since it's x power 3, that means there should be 3 roots and 3 factors. So let's say now I prepare 3 brackets for the 3 factors. And what's the first factor? Have a look at the question here. We know that the first root is this. If a root is -1 plus square root 3i, then what's the factor? For example, if a root is a 1, and what's the factor? The factor is x minus 1. So now we know that the root is a complex root, so it works the same way. The factor is x minus this root. So the root is x minus -1 plus square root 3i. And the other root, isn't it, in part 1 we found out the other root, -1 minus square root 3i. So the factor is x minus -1 minus square root 3i. These are the first 2 factors. So how to find out the third factor here? We have to simplify these 2 factors before we can find out the third factor. So for now, let's simplify this part. So what we need to do now is to expand it. So x multiplied with x, I'll get x squared, and this with this, I will get -1 minus square root 3i x. This with this, I'll get -1 plus square root 3i x. And the last one, notice that this is like a plus b times with a minus b. So we will have the a squared minus b squared. So which is -1 squared minus square root 3i squared. But of course you can choose to expand it one by one. And hence we will have x squared plus x plus square root 3ix plus x minus square root 3ix, and plus over here -1 squared is a 1 minus square root 3i squared, it's 3i squared, and the I squared is a -1, therefore it becomes 1 plus 3, so it's a 4 here, and it will eventually becomes x squared plus 2x, and these 2 terms will be cancelled off, and plus 4. That's how we simplify this conjugate pair factor. And then how to get the third factor here? Yes, it's by using long division. So what we need to do now is to take the polynomial 2x cubed plus 5x squared plus 10x plus a 4 divide by the x squared plus 2x plus 4. So the first value to put is 2x over here, and hence we get 2x cubed plus 4x plus 8x. So 5 minus 4 is 1x squared. 10 minus 8, 2x, and bring down the 4. Then here we just need to put in a 1. Then we'll have x squared plus 2x plus 4, and there shouldn't be any remainder. Alright, so which means this is actually the third factor here. The 2x plus 1 should be here, and hence this gives the third root. So the third root should be 2x plus 1 equals to 0, and hence the third root is negative 1 over 2. That's how we solve for this question. That's all for today's lesson, which is about the conjugate pair theorem. I'll see you in the next video.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.